I'm Michelle Werman, and I'd like to talk about 2,4-D and dicamba drift injury on tomato plants. Tomato plants are highly sensitive to dicamba and 2,4-D. Common symptoms of auxin herbicide injury include bending or twisting of stems, split stems with protruding root tips, plant stunting, cupping or deformed leaflets with a sharply pointed tip, flower and fruit loss, and malformed fruit with delayed maturity. Two important factors that influence the degree of injury are herbicide dosage and growth stage of sensitive plants. Generally, the higher the dose of the herbicide, the greater the injury on sensitive plants. However, a very low dose of 2,4-D can result in hormesis, where the plant growth is slightly increased or enhanced without long-lasting plant injury. Dicamba causes injury to the growing point on the main tomato stem, with increased growth from side shoots, making them bushier in appearance. The most severe injury, including yield reduction, can be found when drift occurs at the flower bud or bloom stages of tomato plants. Generally, plants without visible flower buds or blossoms that are exposed to low doses of 2,4-D or dicamba will eventually produce fruit later in the growing season and recover from herbicide injury. In 1968, a study was conducted to evaluate 60 commercial tomato cultivars after exposure to 2,4-D. Roma is the only tomato cultivar still available today that exhibited a high tolerance to 2,4-D. Recently, researchers at the University of Missouri have been evaluating strategies for protecting tomato plants from auxin herbicide injury. One strategy tested was pre-treating tomato plants before flowering with an anti-transparent to determine if injury from dicamba or 2,4-D could be reduced. Shoot growth of tomato plants were immersed in a solution of either Moisture Lock, True Film, or wilt-proof anti-transparent 24 hours before a low-dose application of 2,4-D or dicamba. At 2 weeks after treatment, plants treated with Moisture Lock or wilt-proof before either herbicide exhibited injury symptoms, but they were always less severe than those treated with the herbicide alone for both cultivars. By 12 weeks after treatment, Moisture Lock or wilt-proof used before either herbicide increased the total number of live buds, flowers, and fruits compared with dicamba or 2,4-D alone for both cultivars. While Moisture Lock and wilt-proof treatments partially mitigated some of the adverse effects of simulated dicamba and 2,4-D drift, they also had some shortcomings. For example, Moisture Lock was the only product among the three tested that is labeled for use on some food crops, but not tomato. Also, tomato plants exhibiting herbicide injury would most likely be non-saleable for retailers. And lastly, fruit harvested from herbicide-injured plants may be considered unacceptable even though it has no detectable herbicide residue or the residue content is below the 50 part per billion legal limit established by the EPA. Furthermore, if tomato plants receive multiple drift events, the film barrier on the plant leaves from these anti-transparent products may crack and be less effective with foliar expansion and stem growth. Others have shown that these anti-transparents protected plants from environmental stress only temporarily. While wilt-proof and Moisture Lock did not provide complete protection against herbicide injury, the concept of using film-forming barriers may be useful in mitigating some of the short-term effects of drift on plants with further work. More information about this study can be found at the site listed on this slide.
Thank you for watching this video. If you enjoyed this video, please make sure that you like, share, and subscribe to our channel, Mizzou Agroforestry.